Hi Harry. Okay, so what I'm going to do is I'm going to read through your essay and I'm going to give you a commentary of the good points and the points that need attention as we go through there, and I'll highlight a few sections as we go. Okay, so your first paragraph is essentially introducing the overall topic. So we're referring to stratification in seawater and the oceans, focused on how different properties of seawater, so salinity, density, temperature, form layers. Okay, so that's good, and you've used the Miller citation there to provide that context. Should be a comma at the end of Miller there, between Miller and the date. So the only thing I would say about that first sentence is ultimately it's the combination of salinity and temperature which control the density rather than the density controlling the others per se. So I'd change the order of that. What you also might want to do at this stage is remove the references to halocline, pycnocline and thermocline because they don't really quite fit in that section. So we can bring those terms back in a little bit later. So we're moving into water mixing, so mixing up that stratification or not can go two different ways, and you're telling the reader, i.e. me, that we're going to focus on stratification with reference to suspended sediments and how both time and different forcing factors cause this stratification to change. And again, another reference. Okay, still need the comma there. So that's a good opening paragraph with a little tiny bit of editing required just to sharpen it up slightly. So the next paragraph, the initial sentence is telling me essentially what is stratification. So changing characteristic of seawater, and you're using salinity as the example. So yes, less saline equals less dense, so it floats, more salty and it sinks. Good. This will cause the ocean to split into layers of different characteristics. What would be nice for this whole section here essentially will be to add in a figure. So if you go to any of the sort of standard oceanography type textbooks, you should be able to find a figure that demonstrates basically a vertical change in density caused by salinity or temperature. And we can really see that stratification, and that would be really good to add in at this point. So the change in salinity, most likely due to the amount of rainfall. Yep, perfect. So if we think about it on a continental shelf example, if we've got a river, let's say local to here, the River Conway, during the high flood season, it's going to be pumping lots of fresh water out into Liverpool Bay. So we'll have a plume of less dense, fresh water. And that's likely to interact in a specific way with the main seawater. And then you're linking in temperature in the bottom here to also affect stratification. And you're essentially doing something called signposting here. Your final sentence of this second paragraph is signposting where the next paragraph's going. That's good. What I'd possibly do though is remove this last sentence here and transfer it to the paragraph below. So now we're looking at this point a temporal change, so during the summer. So we're thinking seasonality, aren't we? So in the summer we've got more heat. Where's that heat coming from? So at the moment you're not specifically saying the heat's coming from solar energy, but you're correct in saying the ocean will be warmer, and during the winter it's colder. So now you're moving on to a spatial idea where you're saying close to the equator it's going to be hotter, which is perfectly true. There's more uniform sunlight there over the course of a year, so the stratification is going to be affected more strongly. Whereas when we move to higher latitudes, the amount of daylight is very, very seasonal. There's also a link here to ice. Okay, so this is good. The freezing side of things here does two things if you think about it. One is the thing you're stating here. So as the water freezes, the salt is ejected from that water, so we form a seawater brine, so the salinity changes drastically. The other thing it does, if you think about it, so sea ice, it locks the top of the ocean away from the atmosphere, so strong winds etc. blowing over the top of the ice can't mix up the water below, so you could think about adding that in there. Okay, so now you're thinking about how do we break stratification. So removing that, okay, so here's the key point. Turbulence in the ocean and the air. So it could be big currents in the open ocean, wind, sea, friction, and the tides. Yep, they all cause mixing of the ocean. So you're now focusing on continental shelves where the tides are the key thing. Yes, very good point. Be a little bit careful about saying there'll be no stratification whatsoever. There's plenty of sections around the UK where there's lots of tidal energy, but seasonally we do get stratification, i.e. the thermal effects of the sun are strong enough to cause summer stratification, but it gets broken down and mixed when there's less thermal energy in the winter. This part of the sentence here, we start mentioning sediments. I think I can see where you're going, that's saying once everything's mixing it doesn't give any chance to settle, but it's a little bit unclear. I'm not fully aware what you're trying to say with that sentence. But this final section here basically saying very close to the coastline where there's lots of energy, lots of interaction from tides, plus we could mix waves in there as well. It keeps everything mixed so we don't have stratification. Okay, so this paragraph going on here, you're talking about stratification related to oxygen content in the water. So what you're writing is perfectly correct, but I think it is a little outside the scope of this essay. So the essay here is essentially split into two halves. What stratification and what controls it, and how does it influence suspended sediments? So yes, the stratification controls the oxygen content in the water, but the oxygen content itself is not causing a stratification. So it's sort of the chicken and egg, which one influences the other. So I personally would remove this paragraph completely, which gives you the ability to put a little bit more detail into the first couple of paragraphs that describe stratification, and this final paragraph here, which I suspect is going to move into the sediments. Okay, so you've made an instant link to the size of the sediment grains. So yes, large grains fall quickly and small grains settle very slowly. So what you're essentially arguing is that when we've got strong stratification, it can cause the sediments to be isolated in one particular layer of the water and perhaps not settle out. So okay, so this is a really key statement. So essentially, fluvial discharge from rivers containing suspended sediments flow out into the ocean, and then depending on whether the water is stratified or not, that controls how that sediment settles out. So if it doesn't settle out, the water is going to remain very turbid and very murky with all that suspended sediment. And what you're now arguing is that close to land there's turbulence in the form of energy from the tides and from the waves and the interaction from the coastline, so that's going to break the stratification, so we might see that sediment settling quickly. So this final bit here, you're talking about open oceans. So you're saying the surfaces of the open oceans are likely to be stratified quite often, so that'll mix sediments up. What we have to really think about though with the open ocean is how much sediment actually gets there. So they're actually very, very devoid of sediment. The open oceans in very deep water are very, very clear. Turbidity levels are very, very low. So the majority of that suspended sediment matter is mobilized and settles out in the coastal regions. So this is moving now into your concluding sentence. What I would do is I'd probably put another sentence at the start of your conclusion, which basically just summarizes very briefly, i.e. one, maybe two sentences, how the combination of salinity and temperature control density, so therefore allow bodies of seawater to stratify. Then it's good that you're moving into the idea of the geographical location, and what's missing is the time of year, i.e. the amount of heat that can heat the ocean, and then perhaps the influence of things like ice can cause changes in salinity and temperature which control the density. You're drawing differences between continental seas and open ocean and telling us there's lots of variation. So I think what you need to do is the conclusion sentence, two sentences here, needs to be extended a little bit, and you can almost split it into three sections. The first section basically says, okay, this is what stratification is and this is what controls it. The second section builds a little bit more on the geographic and temporal scales of stratification. And then the third bit needs to revisit the turbidity or the suspended sediments in the water column and basically build perhaps on that argument how river discharge and stratification be a key factor in stratification on the continental shelves. Let's just have a look at your reference list. So the reference list is not in alphabetical order. So Marshall should be first, Mayer second, Miller third, and then this is a publication from the USGS. Okay, that seems to have all the right information in it. This is a book, so it should have the total number of pages at the end. This is a journal, that looks fine. This is also a journal, that looks fine. So overall I think the key fundamentals are pretty much there. I would add a figure to demonstrate what stratification looks like. I would remove the paragraph on the oxygen concentration and put the majority of those words essentially with ones that would fit into this paragraph here based on suspended sediments, and build the conclusion in a little more detail. But good start.